Sometimes I wish I had X-ray vision glasses when I'm working with students where I could uncover their misconceptions, because they have misconceptions, but it's really hard to know. And this is the kind of problem that will do that for you. So it says using the digits one time at most 2 times each. 2 times is not a common thing. At most 2 times each, place a digit in each box to make an equation with no solutions. So if you're just doing guess and check and you're picking like random digits, 5 and 3 and 6 and 4, it's going to take you a long time. But if you have conceptual understanding, like this will be over very quickly. Because if you think of what does it mean, what does it look like when 2 lines, because these are both separate lines here, when 2 lines have no solution. So when you have 2 regular lines, right, and then they intersect, there is always a solution. But if they are parallel lines, then you start to realize that they will never intersect. So then you start to realize, well, how do you make parallel lines? And now you start to realize, oh, I see why they're making it so we can use 2 digits. So we're going to put a 5 here, and now these 2 lines have the same slope. And so now, if this is a 3, now that actually changes things. It's a special situation where they're the same line, and now there is an infinite number of solutions. And so as long as this is something else, like make this an 8. Well, now we have 2 different lines. These will never intersect. So graphically, we already know we're correct, but just let's see algebraically why that is. So in this particular case, we could subtract 3 from both sides, and then we get 5x equals 5 plus 5x. Whoops. And then we subtract both 5x from both sides. And now we get 0 equals 5, which never happens. And so this is an example where you can actually see both algebraically and think graphically about why this is. And conceptual understanding makes this really easy. But if your students are lacking that, that will become very apparent very quickly.